Okay, today my talking is about one of the most aggressive and prevalent disease in our countries, which is the diabetic retinopathy. Actually, my lecture is it is about my analysis of the surgical forces, which you can use it to get out of any aggressive traction retinal detachment. At first, we have some pathological points which I want to revise. Actually, the membrane interaction retinal detachment, it is not a true membrane. In my point of view, it is just an organized posterior vascularized vitreous which is fixed centrally to the retina in areas which is highly vascularized. We are calling these areas epicenters. This tough vascular membrane is connected to the peripheral retina through transparent vitreous. From this, I want to say that it is not better. It is better to catch the vitreous in the peripheral area first, to have a good edge to cut the membrane. Okay, this is usually better instead of you catch the vascular membrane directly. Okay, so if you try to catch the white edge of the membrane itself, it will be highly vascular, and you will find a difficulty to get under the membrane. It is better to go in the peripheral vitreous and to make a posterior hyaloidotomy. Then you can go and continue your battle under the membrane. According to the extent of PVD, traction retinal detachment can be categorized into a focal traction retinal detachment, in which almost of the vitreous is detached except at one point, and or multifocal traction retinal detachment if the vitreous is still attached at some points, or broad break retinal detachment if almost of the vitreous is still attached to the retina. This is an example of the focal traction retinal detachment. This is of the multifocal traction retinal detachment. And this is a model of the broad break traction retinal detachment. Our weapons to face this aggressive disease, this is the ovally planted scissor for DORC. It is my favorite instrument in this type of surgeries. And the high-speed cutter, as you know, and the serrated forceps. Here we have some surgical points. At first, our goal in these surgeries is to transform the central membrane into multiple bridges. My analysis of the surgical forces are that we are using a mix of forces actually. Some of these forces are non-cutting forces, some other are cutting forces. We have non-cutting forces, which are the horizontal dissection and the vertical pulling, and we have cutting forces which may be vertical or horizontal. Okay, in horizontal dissection, you are separating the vitreous from the retina, so you are creating the bridge. This is combined by pulling the vitreous, pulling the membrane vertically, so you can see the bridge. And then you use your vertical cutting of the body of the bridge, which is called segmentation force. And then you can use a horizontal cutting to disconnect the leg of these bridges. This will be illustrated in the next video. This is a very aggressive broad break traction retinal detachment. This is a demonstration of how the horizontal blunt dissection force it works. You are transforming the big membrane into a small bridges, one by one. Here the bridges are clear. You are seeing points of traction. which are the legs of the bridge. You can cut them one by one. I have an important notice here that don't hesitate to cut them, and don't be afraid from the horrible bleeding, because the neovascular tuft will empty and obliterate because you are cutting the feeders. So they are not connected to the retinal vasculature. It is a very important question, when to use bimanual, when to use unimanual. It is preferred to use unimanual in focal and multifocal traction retinal detachment. It is relatively faster and less costly and shorter learning curve. However, in broad plaque traction retinal detachment, bimanual techniques give you more retinal stability during manipulations and also give you a better view and more control of the bleeders. This is another model of a more aggressive tractional retinal detachment. See, we are trying to open the posterior hyaloid in a transparent vitreous. Yes. So you are creating a functional edge from where you can go under the membrane to take it. This is my preferred way to combine the horizontal blunt dissection with the vertical cutting. In this way, you can see the connecting epicenters, the leg of the bridges one by one, and you can cut them selectively one by one. Notice that the membrane bleeding is controlled. Almost there is no bleeding because you are cutting actually the feeders. So whatever the neovascular tuft is, you can control the bleeding in these cases if you go in this fashion. You should be patient as much as you can. In my point of view, don't hurry to the cutter. You can take it piece by piece in this bimanual way. Here, blunt dissection to separate the retina from the vitreous. And I can see the connecting points and cutting them sharply. The large membrane is separated into two halves. Remember all the time that your membrane is actually an organized vitreous. So after you finish the white bulk, you should search for any vitreous connection in the periphery. Still a horizontal fashion, and we can see the connecting epicenters. Whatever the membrane is, it is just connected with a very small points. If you cut them one by one, the membrane, it is just a game to remove it. Yeah. Okay. Almost we finished. Okay, and finally, you can see your retina. The key of success in such cases is you have to disconnect your enemy, the membrane I mean. You should centralize your battle. This is by peripheral posterior hyaloidotomy, which is the key to cut the peripheral connections of the membrane. Subhyaloid hemorrhage is a good mark to cut the posterior hyaloid safely. and then the avascular edge and the posterior hyaloid is better to go and to be a functional edge to attack the membrane from under the surface. Okay, thank you.
Thank you, Doctor.